So hello and welcome. We appreciate you joining us here for this conversation around securing the edges. My name is Joe Onisick. I am a principal with Transformation Continuum. I've got a very wide background, and so that's kind of the thinking that I'm bringing to the way in which we're looking at security here. I've worked in almost every area of technology, from selling it to designing it to bringing it to market, and to defining the direction of technology for companies. Prior to that, I was a missile guidance system tech in the Marine Corps. I was a low-level electronics tech there. I managed our radiation safety. I managed our maintenance management program, and I was a platoon sergeant. And in my current life, I am a first-generation cattleman, raising cows here in the middle of nowhere. And I am a wannabe cowboy who doesn't know how to ride a horse yet. So I've got some work to do. When we look at where enterprise security comes from, the evolution all started with this perimeter model that we're all fairly familiar with, even if we don't even know the term perimeter model for it. Originally, we didn't secure things, we just connected them. Then we started to add things like username and password as an authentication device. And then we started to build security around the perimeter of our workloads, our servers, our data infrastructure. So things like firewalls were implemented to secure, with the theory that we can keep all of the bad guys out all of the time. And so we built what we considered trusted secure networks. And for a while that worked all right. As we've taken that perimeter model and grown in the way in which we utilize IT and distribute IT, that model has been stretched and adapted to fit the new compute use. So as we've started to need business continuity and disaster recovery, we extended to multiple data centers to be able to achieve that. When we extended to multiple data centers, we created secure connections between those data centers. And those secure connections came in all kinds of flavors, from dark fiber to MPLS circuits, you name it. But basically, we take that perimeter idea, we extend it across multiple perimeters, we connect them with what we consider a secure connection, and then we still use things like username and password to do authentication. In some cases, we added a third factor or a multi-factor authentication device known as an MFA. So we said, username and password is not secure enough. Let me add a third factor that somebody can't know. Let me add a factor that comes from a secure key, a secure token, a secure device. And then we extended this out to users using things like secure VPN. So if you look at what we've done, we've just taken that original perimeter security model and stretched it to fit this more distributed environment that we live in. A VPN is simply an extension of the secure enterprise network out to a user that is not directly connected to that network. So we extend that out securely. The concept here still being that if you are attached to this network, either directly or via something like a VPN, you are secure. And then we layer a second level on that with authorization using username, password, and in some cases, a multi-factor authentication device. So we've extended perimeter in a perimeter extension model. From there, our IT user experience extended again. We started to implement things like cloud and remote. This perimeter extension model that we had, and we stretched it again. We stretched it out to cover software as a service, infrastructure as a service, and other public cloud IT delivery models. So again, within that SaaS infrastructure on the right, or that IaaS infrastructure on the left, we created another set of secure perimeters. We securely connected those with a link that we considered secure, therefore extending what we considered our secure enterprise network. And then we pushed that further out to the users, either through our existing data centers and their perimeter security, or directly to those cloud infrastructures with their data center security. As we've extended this out, what we're really doing is taking a very old view of how to secure IT assets and trying to readapt it again and again to the way in which we actually utilize those assets today. And at some point, this perimeter model stretched thin. and we get what I love to call perimeter explosion. I'm trying to secure a dozen different perimeters, connecting them securely together, and then authenticating users against that big, broad enterprise network. And you see this done today in security with a lot of what we would call cutting edge or next generation security tools. You see it done with secure access, secure edge. You see it done with SD-WAN solutions. There are a lot of new technologies that are simply this old trick of let's assume the network secure and extend it securely to more and more assets, and then from there to more and more users. But what we end up doing as we do this across multi-cloud, public cloud, or hybrid cloud environments is we start to show our as a service a lot. So what's the problem here? The problem is we're assuming that we can create a secure perimeter, and within that secure perimeter, we are safe. Externally, the network is unsafe. Internally, the network is safe. The problem is we can't secure against every threat every time, no matter how good we are at it. So what happens if I have the assumption that my perimeter is secure and somebody gets in through that perimeter? So think about putting up a giant barbed wire fence, and you put up this giant barbed wire fence and you assume it's completely secure, so you don't lock any of the doors inside that fence. Well, if a tree falls down on that fence and somebody wanders through, they now have complete access to everything inside your secure perimeter. They now have access to all those unlocked buildings. Well, that may not be desirable behavior. Same thing exists here. If some clown is able to penetrate that perimeter and their code is able to access one of the devices within that perimeter, I've now got some sort of malicious operator that exists inside my perimeter. If my security is fully focused on the concept of the perimeter, then they now have free reign to move throughout my environment. From that single penetration of one vulnerable unpatched server among thousands, they're now inside my security zone, able to propagate at will, or at least theoretically propagate at will. And they can, in many cases, do this very, very transparently. Just like cockroaches, whenever you turn the lights on, this malicious code is going to be hidden. You're not going to see it. So as it propagates, it may take a while for you to find out that it's there, meaning you've got a whole lot more exposure in the process. The next problem is that if this area was considered secure, and I've gained access to one of your assets in this secure environment, I can now theoretically extend my penetration out to anything that is connected to this perimeter. So if we look at that perimeter explosion and we're building a bunch of secure perimeters, connecting them with assumed secure links, I can now use those secure links to propagate out to your other data centers, to your infrastructure as a service assets, to your software as a service assets, and theoretically directly to your data. This is the perimeter problem. This is the problem with taking an old hat style of thinking, an old hat theory or strategy for security, and trying to continuously readapt that same concept to modern security problems and modern user expectations. So what we need to do is rethink how we look at the perimeter itself. And there are a lot of ways to do this. You'll hear a lot of talk in the security world today about things like microsegmentation or zero trust. The idea there being microsegmentation will bring that perimeter down, creating smaller and smaller perimeters within your given perimeter. And zero trust is the concept of really not zero trust, but minimal trust or least privilege access. It's not trusting anything by default, meaning based on the fact that it's on a network or based on the fact that it's within a perimeter. It's creating an authentication at every single step without assigning default trust based on some other piece of context, like a network connection. So as we start to rethink this, we really need to expand the model we use for securing assets. We need to think of the perimeter as the center of kind of a security sandwich. On the top, we have our data edge, where we need to provide security tools for the data itself. If a workload asset is compromised, should that workload asset have free range to access the data that it's uses? Probably not. So how do we look at security at that data edge? On the bottom half of this security sandwich, we've got the access edge, where we're authorizing access for the users, devices, things, and software that's accessing other users, devices, things, and software. So we look at security in 3 different broad stroke areas: at the data edge, at the access edge, and within that, at that compute perimeter, where we're doing the heavy lifting of processing the data. So let's drill down a little more into each of these existing edges. First, when we think about access, access has expanded quite a bit over time. Access was originally users accessing systems. We called it a client-server model. Access extended into services and applications accessing other services and applications. Access extended again into devices and things accessing other services or users. So we lump all those together into the device. What is creating the access? In security terms, this could easily be called the actor. What is creating the action, or the access action in this case? Next, we look at the operation they're performing. So what are they doing? Are they uploading a file? Are they accessing data and downloading it? Are they trying to replicate it? Whatever that operation may be, it's irrelevant what the operation is, but that's an important piece of this. Joe might have access to read data, meaning pull that data, but Joe might not have access to modify that data. So we use the operation as a piece of how we decide on a security action. And then we have the device being accessed, or the application, the resource, the service, however you want to term that. That can be data, it can be systems, it can be an application. Within an application, it can be a specific function. So if you think about a software as a service application, they'll often give me some role-based access control, where I can assign Joe a role where Joe can go look at everything in that system, but Joe can't change anything in that system. This is the way security lays out most times today. It's this user has access for these operations to these applications or systems. This view of security is better than where we've been, but it's still missing a lot of information. And it's still very reliant on ideas like default trust. A VPN is a great example of default trust. If I connect this PC to a VPN, what I'm doing is extending this quote secure network to this PC. So anything on that network segment at the other end of the VPN is in a trust zone that I've now connected to, extending to my PC. So we're still using a lot of default trust based on network operations or network connectivity. What we really need to do is get past that default trust on the network, utilize this security mechanism. Can this user perform this operation on this application, device, piece of data, or system? But we need to extend this model to incorporate some very critical data that really isn't used today. And that data is context. So context can be, is Joe doing this from the corporate office? Joe might be allowed to do this from the corporate office, but Joe might not be allowed to do this from a campus or from home. We need to know location, things like business travel, right? So can Joe do this while traveling? European compliance regulations are a great example of this. Things like GDPR protect the privacy of users. So there are data items that I can legally access within the European Union that I would not be able to legally access outside of the European Union. So the context of where I am is critical to the decision for authentication. Other pieces of context come into play quite a bit, and they're extremely important and almost ubiquitously ignored. Is Joe a new hire? Maybe Joe, as a new hire, has limited access to certain functions. So if we think about Joe as a developer, if Joe is just hired, maybe Joe can go review our code on GitHub, but Joe cannot make Git pushes. Joe cannot push new code to GitHub. Or maybe Joe can't push to a main branch or to a production branch because Joe's in a new hire period and we're testing Joe out. Maybe Joe just walked into my office and turned in his 2 weeks resignation. Well, after turning in his 2 weeks resignation, we may not want Joe downloading all of our source code or downloading IP information, intellectual property, or confidential information, whatever it may be. So adding context to security authorization is critical to moving security forward. It becomes the actor plus the operation connecting to the what resource in what context to create security. So we end up with, can X perform Y on resource A in context B? Or in human readable language, can Joe commit code to production while on vacation? These are the real security questions we need to be asking. Not, is Joe on a secure network, trusting that network, or is Joe allowed to access AWS? So we take that access edge where we're authorizing actions at the most granular possible level, and we layer that into the bottom of our security model, maintaining perimeter security in the middle, but augmenting perimeter security with a much more granular access and authorization system. Next, we need to look at the data edge. How do we start to think about our data? Step one is classifying our data, having a good idea of how important data is and how important a specific data set is, more importantly. So we can classify that data in many different ways based on compliance and regulatory concerns. We can classify it based on its value to us. There are companies that we work with that are out there classifying it based on its value to the dark web, its value on the data black market. So think about that. They're going out and seeing how valuable your data would be if somebody could access it, and then assigning a data classification based on that. I know that this is extremely valuable on the black market of data, so let's protect the heck out of it, because just like we would a bunch of gold bars. So step one is picking a way to classify that data based on whatever your classification requirements are and classifying that data. Data pool A is critical to me, data pool B is less critical. Data pool A is valuable to me, data pool B is less valuable. Data pool A is compliant with regulatory concerns, data pool B is not. Now I need to take that classification and understand where my data lives. So we often think of data as sitting in a single location, but typically data has a primary location. It may have replication locations. It may have backup in DR locations. And that data also may be copied out by users, by systems, by other tools for other purposes. Maybe your developers have a data set that they've copied out from a production data set to use as test. Do you know where all that replicated data lives? So having ways to understand and track your data as it's replicated out, or as it's moved to other locations, or as it's copied out for specific operations, becomes extremely critical. I know how valuable the data is based on my data classification. I need to know where that data is replicated, so I know how, when, where to protect it, and also so that I know what my exposure is. What this becomes is my ability to create security zones for my specific data. It's not just that important data on the bottom left that I've classified, it's the security zone for that data in its primary location and in any other locations where it's replicated. And I need both visibility into this and a way to ensure that it receives consistent security wherever that data goes, or to enforce security when that data shouldn't go somewhere. So this helps me secure my data edge. From there, I need to bring these things together. I need to take what I've got in perimeter security and make sure that it's modernized, and set up correctly for the way in which perimeter security recommended practices work today. I then need to layer on a more granular access edge that takes into account the context of an operation before authorizing the action. So I need to be able to take the user, the operation, the resource being operated on, and the context of all of that, and make a security decision based on that. And then at the top, I need to be able to look at that data edge, understand the criticality, the risk, the cost associated with my given data sets, understand where those data sets live, where they should live and where they shouldn't live, and be able to track that and apply security zones to the data itself. What this allows me to do is ensure that my perimeter security is keeping as many malicious actors out as possible at all times. But when something does get through the perimeter, its ability to propagate, to access critical data, to access critical systems is mitigated or minimized as much as possible by layering in more intelligent security. So sure, you've penetrated my perimeter with a zero-day attack. You've got malicious code running on one of my servers. But when that server tries to access my software as a service platform, that access is prevented because no server in the data center is supposed to be accessing the software as a service. So the context tells me no. Bringing this all together is really where security will need to move in some way, shape, or form to be able to handle the rapid adaptation and growth of malicious attacks, things like ransomware, which we hear about in the news all the time. We at Transformation Continuum are working with several clients to be able to build out these security architectures, as well as several security startups and security vendors who are working on solving these problems in many, many different ways. So if you have more questions, would like to chat about this, if you'd like to understand how this all gets applied or make it more tangible and tactical, please feel free to reach out. We're happy to jump on a call, have a conversation, and see if we can help. Thank you very much.